very important to understand now. ISIS, guys. ISIS is like really annoying me. So basically, I'm trying to do this properly. I do want to just guys. Do everything else. Focus this calculator. Focus this calculator. This image job. So basically, you got the compound. Basically, you got no houses. Basically, no guest houses, but you get houses just to believe. That means this is how it works. So you get how many so you get everything in tridents maximum. So you can grow in trident clusters. I don't care whether it's 10, 15. You have to be in like a trident. So example, houses. Everything housing that gives this housing the ground to free. Food, water, shelter, free. Then we get business. Business. So 3, you get a compound. The compound, which is the space of 15 acres. 15 acres. 15, 30. 30 acres. Yeah, 30 acres of is standard compound. So 15 acres is like 15 meters. 15 and 15. So 15 radius, and then 30 radius. That's just this is all circular. So you got the policy now. 30, 15. That's just 15 meters, 15 because 5, 10, 15 goes with 5, 5, 10, 15. Then you got 10, 15. Because I'm thinking about Nigeria basically. 15 acres squared. 15 to squared is what? 225 square area per the acres land. Because I got the basically got the acres, got whatever miles, whatever the equivalent is miles. Basically got that we got the whatever the equivalent is miles. But you got 30 times to the power of 30 squared is what? 900. Now 900 acres of land. Look guys. I don't really care no more. This is the policy now. 15, 30, 45, 30, 45, 30, 45, because you got 15, 30, 15 is the policy. So you get the houses, houses free, food order is free. Those are free. So this is what I say. So how does this work? So you got the standard bit max operation. So you get 9 to the power of 3. That's what? The compound. Now, the compound is not fragmented because you can mathematically verify it. So basically, you get bit mask equals. So you can check with an equal sign and you gotta add some values. But I don't have to do that. Let me try to do that mathematically. I'm gonna try to find a calculator. I can do that. Basically, it's the same. Basically, the system remembers the state. So binary calculator. Basically, you got a bit mask value. So the binary calculator is this. You get like what? The number what? 9. So you get trident. So you get yes. Wait, this is going for me. So you get the compound, which in trident, and that trident is like 1, 2, 3, 3 of 3. So that's all circular. Basically, it doesn't matter how you organize it. You have to fold and stuff. Basically, you have to have some kind of way. In this car, you have to have some way, like a red RGB colors that you can look at based on. So you have to notice unfragmented. So you get negative space, and that negative space is just like you looking at space that no one needs. Because if no one needs a space, that means you can build more, you can expand it. So basically, it's like tomographically space. So you will get a red, green, blue. It's like me looking through the red, green, blue with some goggles. I'm looking at red. You are seeing what? If I'm looking at red, you are basically. If you're looking at me, my red is like you moving away from me. So if I'm with you, I'm growing. I'm growing hours. But if you're seeing blue, that means you're moving. I'm seeing blue. You're moving away from me because I'm not moving. Because if I'm moving away, I'm seeing red. If you're moving away, I'm seeing red, green, blue. But if everyone's moving away from us, we're seeing green. Basically, that's the opposite of cyan, cyan, yellow, CYMK, cyan, yellow, magenta, cyan, CYMK, magenta, and the K's. I don't know the damping factor. I don't know what K stuff. Basically, that's what you print out. But isn't the middle definitely based on that's where the white spaces because there are 4 white spaces. Basically, there are 3 white spaces. Alpha channel CYMA. There are 4 alpha channels. The alpha channel just needed for the 3 you get the 3, you get 6, but you get extra space. This is an alpha channel to the red zebra and get some CYMK the kilo the kind of 5K value, which I don't know what it means. So that represents opacity because you don't need no space. You just this beautiful space just to look at. There's negative space is there to look at, and that's what I like to see. My constitution. There's no fragmentation. For example, you get a separation you can do. So how you verify is this, guys. It doesn't matter who you are. You are 3 to the power of 3. You know, 3 to the power of 9 as well. 3 to the power of 9 is 19,683 people in a compound. Basically, if there are three rings or three zones and three rings, you get the maximum of 19,000. You know, and the perimeter is not valid. You know, valid. You can add more stuff. You can remove more stuff. You know, basically 19,683 people can literally be there. You know, at a time. You know, just living there, breathing the air, you know, and living there, like living there, and working there, you know. But you know, because of the space, you have to calculate pipe equals because you know people move around on the BBS stage. I don't even know how to do this, but you know, the pipe equals is like the mask. I'll process your masks and you equal it, and that'll equal to this. For example, that'll be 3 mask, 3 pipe. Basically, 3 pipe equals, but I don't have to do it properly because you know, use XOR. Basically, you store the value, you store what happens with XOR, and you pipe with the mask equals. So let me do 3 power 9. Again, this is 19,683 people maximum. And they get 3 to the power of 9, 9 to the power of 3. 9, okay, 3 to the power of 9. And they get 3 times 9. So basically, this is what 77. This is like the medium. This is 3 times 9. Because you get 3 times 3. 3 times 3 is 6 times 3 is 27. So you get 3 to the power of 3 is 27. And this 27 is the power of dimension. So you get that 3 to the power of 9. And get 3 times to the power of 3. 3 times 3 is 9. So basically, if you have 2 dimensions of it, you get 2 rings, and you get 3 to the power of 3. 3 rings as well. And this is the maximum you can get. So 3 to the power of 9. 9 rings is like the dimension rings, and this is how many people in those rings, like literally at a time, it is from But basically, you're trying to distill everything into something else because people are gonna move it out anyway. But they're gonna go to work and move out, and they get 3 to the power of 27. This one's like the dimensions you are basically. This is like one's really busy in one location. So basically, this kind of people you're gonna have there. So this is computable. So it's actually humane. You know, 7,625, 5,000, Basically, this is like a very high number. This is over a million, 6 billion. Wait, 1, 2, 3, 1, 2, 3, 4 billion. No wait, This is 5. 1,000, 10,000, 7,000. 7,625, 10,000, 597. 100, no, 1,000, 482, 400. This is annoying me because like it matters to me. So basically, can you use those numbers? Basically, the pipe equals is like the mask operation. It marks something, and then I can't find it. Basically, let me just put this number here. It should work, Andy, innit? So basically, bit mask of this should be. So basically, the bit mask is like if you want a bit mask equals to the original capital state, you can put that equal sign. But that bit mask is not really needed unless you put some kind of sign there, so you can see experiment with it to see whether it reduces to 0. You want an output of 0. That's for your model because if you bit mask on your remember basically. If you do bit mask equals 0, that means you are sure that it equals to the area and the state of what or it was preserved. So the binary value of this decimal. So basically, this is my the 2 numeric. I think it's a numeric number, but it's like it's going. I don't know. This is my binary value. Convert binary to decimal. This is one binary value, and we get divide. So basically, you have to mask it. I don't even know how to build mask calculator. Basically, the mask, what the mask does, the pipe operator, the mask operator is very needed. The pipe operator, what does, it remembers the state, it holds that state in memory. Basically, if a pipe, 5 pipe 0, you get the size of it. So that's very important. But if you get pipe 50 equals something, that equals something is the dimension. So if you get an option number 5 in binary as well. Okay, let's use 8. Let's use 2 bytes. Let's use the number 8. So let's use the number 64 because 8 to the power of 4. 8 to the power of 2 is 16. 64. I don't know. 64 is related to somewhere in my memory. So that's 1,000. But basically, this isn't. It's just flop. Not flop. Basically, anyone can move somewhere. So basically, Let's look at the function we're talking about. Basically, you got the binary values is the 4 here, and convert by to decimal, and this is like binary. So this is like 101101101011. Basically, when you do the power of, you pipe it to the power of it. So basically, the pipe operates to the power of something. So you don't keep it as one state. You can, because you're working on errors with it. It's like working on conjugate stuff, but you have to separate it into segments so it doesn't get fragmented too quickly. It's like basically it's like the power of, it's like the inverse power. Basically, you're trying to power down, but you don't pipe it. Basically, when you times it, your pipe is 10101010. It's numbered 64. 64 divided by what? 4. Start should be 4 would be what? 4 would be what? 4 8. 4. Let's see what it means for. Because I'm trying to get 8 for 100. I don't even think I'll get it. That'll be 174. But this this is the one I needed. This one is 70. This one is 7. This is 64. This is the second number. 1000. This is memory. So binary value is 100 divided by 74. Basically, I'm trying to do it properly. So the number 64 plus divided by 204. No, not 204. Divided by 4. Let's just type it in. 1, 2, 3. 1, 2, 3. 0, 1, 2. 4. Okay, that's basically 64. That's 72. So you get 72 square acres. Wait, 1, 2, 0, 1, 2, 3. 1, 2, 4, 8. So basically this is 4, 8. 1, 2, 4. 1, 2, 4. So this number is okay, basically you get 64 divided by 4. So you get 68 people. Basically, just physically, it's like, there are 2 person at one area. This is an area. There are 4 people. I don't know. 4 people per area. That means the space of breathing room of 2 more people. Maximum. You know what I'm saying? Because you don't wanna. Obviously, basically, remember the state of it. You can try to up it in binary. Let's see what it becomes. Basically, as a policy, this is a policy that you enforce. Doesn't matter where it is, because you go in and out. I don't care how dangerous it is. So that is divided by 12. Now the area, what is the area? I think so. 64 divided by 12. So the area has to be 76. If there's 64, no, if the area is already this, that's be 64. Because I'm thinking now. So basically, the area is 64. No. Yep, there is 64. Why? 8 times no 64 area done divided by 12. That means there's 64 people there in battle. Because these 8. No, area. This is area. This is 4 squared. So basically, it works as intended. That means there's 60 people. Because if it's the area, it works backwards too. So that works really. 64 is 64 times 2. But I didn't put that possibility. Did I? Let me try 8. I think 8. The number 8 should work. So I don't want to use 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 4. I don't know. But yeah, usually you just meant to remember what it is. The number 8 is 110 1011 110. Oh, 8 divided by 2 to the 4. Basically, it's like an overflow. Basically, if the error is 8 squared, that'd be what? 8 to the power of 8 squared, that'll be 8 times 8, that'll be 64. Ah, this 8 squared, it is 64. This would be 204 people. So 8 and 4 will be 1, 2, 4. Calculate. That would be 12. 8 divided by 12. So basically, 12 people in 8 squared for each area. 4 people maximum. No, 4 basically. This is half the area. So this is like this is people here. This is half the area. This is like if the area is 3, basically divided by 4. That'd be 3. So 8 plus 4. If the area is 4 for every 4 half area of it, which is arbitrary, but it should be 3 or 4, which is still reliable. But it should be 4, but I want it to be 3, so let me just put 3 down. 0, 0. So number 3 is what in binary. 0, 1, 1. 0, 1. Look at that. W 1, 0, 0. Oh, this is plus in me. Don't plus enter for me. Oh, 10 divided. Okay, this is divided. This is 8 divided by 3 is 4. 2 remainder. But this 2 remainder is masking, so it divides and then it divides is equals so basically 10 2 remainder 2, but 2 spaces remainder. And basically, you have to ensure that there's flow, and that's 6 basically. It's not 6 basically. The spaces is places remainder, and you keep all the decimal places. It's like it's calculated because the masking operation is there to do it. And that's it. Basically, you get the extra. Basically, like remember the state of the area, and look and globe between white space. Because if it's white space, if there's nothing to do for people in that area, so it should be there. Basically, white space is like the science. Basically, as a policy, should be in the white space. As a policy, because the white space is just for looking and like just breathing air. Breathing only. But no living there because you don't need to work there. As a policy. Because I don't work in some places because I don't care what it's like a nice place to look. It's just a sightseeing. It's actually allows you to see everything and anything as a policy. That's why space. Basically, doesn't matter where you are, should be to get to some kind of area from because it's a center thing as a policy. No, thank you, Einstein. How are you? Why are you in my head? Oh, I'm a philosopher now. I'm sorry. Thank you very much. But why? Why me? Oh, you want to know? Oh, I know. Want to know too about you? Okay, I'm a philosopher because of us.